Okay, so what if Roblox had black holes? Alright, what even is a black hole? So a black hole is just a region in space where gravity is so strong that light can't even escape it. Now, as described by the theory of general relativity, gravity is explained by the curvature of space-time, not just a simple force. In relativity, mass curves space-time, light follows these curves, and time itself can slow down near a black hole. And space-time has something to do with geometry, but here's the issue. Roblox physics, however, is Newtonian. Space is fixed, time is uniform, and light doesn't exist as a physical particle. You can't even make custom shaders to approximate black hole lensing. But since this is about gravity, I guess we should start with Newton's law of universal gravitation. This essentially just states that every object with mass attracts other objects with mass, described by a force. The force gets weaker by distance, and that's boring. So let's just apply an initial velocity so that it doesn't just fall directly into the mass, or the tangential velocity, which gets us pretty cool orbits like this, or this. Also, by the way, this is a form of the two-body problem. Here are some more clips. But how do we go from this to a black hole? Well, if we just keep increasing the mass in Newton's law, the gravitational pull gets stronger and stronger, and eventually you can define something called the escape velocity, or the speed you need to actually break free from gravity at a given distance. From Earth, that's about 11 kilometers per second, but for a black hole, the escape velocity at a certain radius exceeds the speed of light. That radius is what we call the event horizon. Also, Newton's escape velocity formula surprisingly aligns with the Schwarzschild radius if we just set the escape velocity to the speed of light, but keep in mind that the interpretation and context are different. Anyways, let's continue. But Newton's law by itself is too simple. It predicts neat paths like ellipses and parabolas called conic section orbits, but it doesn't really explain weird effects like Mercury's orbit precessing with the extra 43 arc seconds per century, or how light bends around a star. Now, obviously, I can't code the full theory of relativity into Roblox, but what we can do is add a tiny correction to Newton's equation, and it looks like this. Don't worry about don't worry much about the math. It just adds a little extra pull whenever you're close to the mass you're orbiting. And this is what it does. So essentially, the orbit doesn't close perfectly anymore. Instead of repeating the same ellipse again and again, the closest point to the mass shifts a little each time. And this is pretty much just precession, which matches reality much better with examples such as the precession of Mercury. So here's a quick recap. Newton gives neat ellipses, add a tiny relativity tweak, and they precess like Mercury. But that's still math. Where do you actually get black holes? Well, a black hole has a ton of parts which I probably won't make, so I'll just focus on two things. The Schwarzschild radius or event horizon and gravitational lensing. So here's the event horizon, the invisible boundary where nothing escapes. So let's just watch this block fall in. Why isn't it falling in? Oh wait, that's called time dilation, where time slows down near a black hole so much so that from your perspective, the block appears to freeze right at the edge. Also, because of the strong gravity, light has trouble escaping and its wavelength is being stretched or redshifted from an external observer's point of view. And that wavelength will be stretched so much that it no longer lies in the visible range in the electromagnetic spectrum. And because time near a black hole is moving so slowly from our perspective, the block appears to freeze and gradually fade from view. So let's program that in Roblox. Not just kidding. I don't feel like programming that. I mean, maybe we could make the parts turn red or something and also slow down its velocity, but that would require a client since we need an observer right now we've been using the server's point of view. Also, if you've seen my video on the speed of light, that's gonna require some remote events and client manipulations, which I don't really feel like doing. Now, let's talk about gravitational lensing. This is where a massive object, like a black hole, bends the path of light around it. So, the light behind a black hole doesn't travel straight into your eyes. It actually curves around the mass. In reality, this is because mass curves spacetime itself. Light always follows the straightest possible path in curved spacetime, and that straightest path is a curve. Now in Roblox, we can't actually bend light, so I was researching this on the dev forum and found this post about black hole lensing and found that you can do pretty cool stuff with the glass material. So I got his model and it was pretty cool, but I searched even further and found this YouTube channel with an even better model, but the effect is, nullified once I scale the model. Having cool rings is pretty cool, but I just opted to use one mesh for the lensing. Also, hey, here's a clip of the black hole moving around. Anyways, for the event horizon, I'm gonna keep it simple and just destroy the part and use get mass to add mass or size to my, black hole thing. To add more customization though, I also added this mass attribute because custom physical properties has a limit on density. Now, black holes don't absorb mass instantly. Matter falling toward a black hole usually form an accretion disk first. Friction and heating cause it to spiral in over time. But, you know what, let's just simplify this. Black hole gets bigger with more stuff. Let me just check if that's accurate. Okay, so yeah, a black hole gets bigger with more stuff, but how do we actually measure how big it is? And that's where the Schwarzschild radius comes in. Basically, it's just the radius of the event horizon, the point where even light can't escape. That's a massive oversimplification. But wait, the Schwarzschild radius comes from solving Einstein's field equations for a non-rotating, uncharged spherical symmetric mass. But honestly, bro, this is Roblox. So plus, I'm not even using accurate values for the universal constants. Like, what? Anyways, so yeah, the Schwarzschild thing only applies for non-rotating black holes. Real black holes usually spin, which is described by the Kerr solution. Anyways, now we have this black void with a material of neon. The next step is to determine the size of the gravitational lensing. But since we aren't actually bending light accurately, I'm just gonna use something called heuristics. Wow, so where I basically just make the radius of the lens 3 times the Schwarzschild radius for purely visual reasons. Alright, this isn't accurate, and maybe we could even at least model a simple version of an Einstein ring to get the approximation of the lens radius, but hey. Now we have a pretty cool looking fake black hole. And here are some cool clips of its destroying stuff. It's still pretty bad at handling players though, even when gravity is disabled. Also, the gravity isn't that strong because if it was, then the parts would instantly get grabbed and disappear. Anyways, that's all. Bye. You can send me feasible video ideas in the comments and I'll pin them. Maybe.